You are welcome back from break. Let's continue from where we stopped the other time. Let's consider example 4. A number selected at random between 20 and 30. Both numbers inclusive. Find the probability that the number is a prime number. You can see here that element of confusion is in this question, but don't be confused for once. Between 20 and 30 suggests that 20 and 30 will not be parts. But to now make them to be parts, another phrase is included, both numbers inclusive. That automatically includes 20 and 30, yes. So how do we now go about that? From 20 and 30, how many numbers are present there? We have 11 numbers present. How? Just subtract 19 from 30. Subtracting 19 from 30, you have 11. The reason we are not subtracting 20 from 30 is that now we are including the 20. If we subtract it, it will give us just 10. But the number should be 11. So we have 11 of them. Among them, how many are prime? Let's see. From 20, 21, 22, 23. Yes, 23 is prime. 24, 25, 26, 27, 28, 29 is prime. Then 30. Count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11. So the probability then will be equal to number of required outcomes. The required outcomes are the prime. The prime. Let's read the question again. Find the probability that the number is a prime number. The number that is a prime number here, 23 is a prime number, 29 is a prime number. Now, their number is 2. So you have 2 all over total possible outcome, which is 11. The correct option is option A. Do you understand? Example 5. A crate of soft drinks contains 10 bottles of Coca-Cola, 8 of Fanta, and 6 of Sprite. If one bottle is selected at random, what is the probability that it is not a Coca-Cola bottle? The word not a Coca-Cola bottle is a term in probability. In probability, when you hear not a Coca-Cola bottle, it means, so probability of not a Coca-Cola equals 1 minus probability of Coca-Cola. Coca-Cola. That is a term. And don't forget, anytime you have to find probability of not getting 5 means 1 minus probability of getting 5. Probability of not going there is 1 minus probability of going there. Therefore, probability of not a Coca-Cola equals 1 minus probability of Coca-Cola, which is 1 minus, what is the probability of Coca-Cola in this case? Probability of Coca-Cola is, the Coca-Cola in that case is the required item. What is the number of Coca-Cola? Number of Coca-Cola is 10. Yeah, 10 over. Number of possible outcome is addition of all of them, 10 plus 8 plus 6. That is definitely 24. 24. So we have 1 minus 2 in 10 is 5. 2 in 24 is 12. Subtracting 5 over 12 from 1, that gives 7 over 12. Do you know how fast I get that? You don't need to, at this level, at your level, you don't need to be looking for LCM for this kind of work. Just subtract 5 from 12, you have 7. The answer is 7 over 12. And that works everywhere, anywhere, at all times. So 7 over 12, and that tallies with option what here? Option D is the correct option. Example 6. A man kept 6 black, 5 brown, and 7 purple shirts in a drawer. What is the probability of his picking a purple shirt with his eyes closed? Let's get into it. Required outcome is 7 purple shirts. That's the required outcome. Total possible outcome is the addition of 6, 5, and 7, which is 18. Therefore, probability equals number of required outcome 7 over number of possible outcome 18, which tallies with option C. Option C is the correct answer. Let's consider example 7. The probabilities that John and James pass an examination are 3 over 4 and 3 over 5 respectively, meaning that the probability that belongs to John is 3 over 4, the one belonging to James is 3 over 5. Find the probability that both boys failed the examination. Both boys failed the examination. This is it. In this kind of probability, we call it given probability. John's success probability is given as 3 over 4. John's failure probability is 1 over 4. What do? You subtract the success probability from 1 to get the failure probability. The same thing applies to James. James' success probability is 3 over 5. Therefore, failure probability will be you subtract 3 over 5 from 1. You have 2 over 5. Now, the question is, find the probability of both boys failing the examination. Therefore, probability of both boys failing equals that of John, 1 over 4 times 2 over 5. And that is 2 here, 1, 2 in this 2, answer is 1 over 10. The correct answer, the correct option is option A. Let's consider example 8. If x, y can take values from set 1, 2, 3, 4, find the probability that the product of x and y is not greater than 6. When you see a question like this, don't let it disturb you. Let y be here, x be here. You can put y here, x here. Just put 1 anywhere. Now, let y take the value 1, 2, 3, 4. X take the value 1, 2, 3, 4. They are products. That's multiplication. 1 times 1 is 1. 1 times 2, 2, 3, 4. 2 times 1, 2. Times 2, 4. Times 3, 6. Times 4, 8. 3 times 1 is 3. Times 2 is 6. Times 3 is 9. Times 4 is 12. 4 times 1 is 4. Times 2, 8. Times 3, 12. Times 4, 16. Now, the number of possible outcomes here is 16. As you can see, 1, 2, 3, 4. 1, 2, 3, 4. 4 times 4 is 16. And if you count them one by one, the values inside the table, they are 16. So that gives us the possible outcome, 16. The required outcome here will be the product of x and y that is not greater than 6. Which ones are not greater than 6? This is not greater than 6. The ringed one, the ones I'm ringing, they are not greater than 6. Even the 6 is not greater than 6, so it's still part. Yes, 4. So how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The probability equals the number of required outcome, which is 10, whole over number of possible outcome, which is 16. Reducing it to the lowest term, 2 in 10 is 5, 2 in 16 is 8, and that is 5 over 8, which tallies with option A. Option A is the correct option. Let's consider example 9. The table below gives the marks scored by a group of students in a test. What is the probability of selecting a student that scored 2 or 3? We have the options. Probability of 2 or 3 equals this probability of students scoring 2 is, this is number of students that could score 2 here. That's 7. That is 7 over total possible outcome is the total frequency, which is 22. 1 plus 2, that's 3 plus this, that's 22. In probability, or means addition, you have probability of scoring 3 marks. The number of students that score 3 marks is 5. 5 is the required. Total possible outcome is 22. Do you understand? So we have 7 plus 5 over 22. That is 12 over 22. The probability of 2 or 3 is 6 over 11. Reducing 12 over 22 to its lowest term, that is 6 over 11. 2 in 12 is 6, 2 in 22 is 11. And that is option D is the correct option. Let's consider this example 10, which is going to be the last example drawn from past questions that I'm going to treat with you. After this, I want you also to go and try your hands on different types of questions you might come across in past questions, and I'm sure you are going to get it. So, example 10, which is the last example I'm going to give you in probability. The table above represents the outcome of throwing a die 100 times. What is the probability of obtaining at least 4? The word at least 4 means 4 and above. That is 4 and above. What's the probability of obtaining 4 and above? Is the probability of obtaining 4 and 5 and 6, which is probability of obtaining 4 and above. That's the meaning, that's the interpretation. And number of required outcome here will be the number of 4 plus the number of 5 plus the number of 6, which is 16 being the number of 4 plus 10 being the number of 5 plus 14 being the number of 6. Addition of that should give us 40. That is 40 as our number of required outcome. All over number of possible outcome. The possible outcome is the total frequency here, which is 100 as given to us in the question, 100 times. 18 plus 22 plus 20 plus 16 plus 10 plus 14, that is 100. Reducing this to the lowest term, we have 0 take care of 0. 2 in 4 is 2. 2 in 10, that is 5. That is 2 over 5, which tallies with option C here. And that is the end of probability. In the next class, we will be looking into statistics. Till then, bye.